This is Algebra 2B, Probability Lesson 6, Expected Value. So expected value is another way to say average outcome. It's important to note that our outcomes do have to have a number, right? So I can't say average. I can't take the average of heads or average of tails. I have to have the average of a number. And we're going to use this table that I have created to do the math for us because the formula looks kind of complicated. But what you need is you need the outcome. And again, that outcome has to be numerical. You are going to multiply it by the probability of that outcome. And then you are going to add them all together. That's capital letter sigma, which we use in mathematics to denote a sum. So one more time, you need your numerical outcomes, you need the probability of each outcome, you need to multiply those together, and then finally add them up. And luckily, each of these problems have a handy-dandy table that will do most of that work for you so long as you put everything in the right places. So let's try one out. First example, we have a dot plot. It shows the sizes of 25 puppy litters. If a veterinarian randomly selects a puppy litter for a health check, what is the expected number of puppies that he or she will check? So, possible outcomes. That's what X is. Possible outcomes. There are no litters with 1 puppy. There are no litters with 5 puppies or 7 puppies. Our possible outcomes are 2, 3, 4, and 6. That's the only place I see data on our dot plot, so I'm going to skip the other numbers. Next, we need the probability. So P stands for probability. The probability of a litter having 2 puppies, okay? If we look at the 2 column, I got 1, 2, 3, 4. I have 4 dots, so I have 4 puppy litters out of the 25 in the graph. So there is a 4 out of 25 chance that a litter will have 2 puppies. Looking at the 3 column, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 litters at this shelter that have 3 puppies out of the 25 litters altogether. 4 looks like 1 less, so I'm not even going to count that out. I know there are 8. And 6 puppies. Oh my goodness. There are 3 litters that have 6 puppies out of the 25 at the shelter. Okay? So we have our outcomes, 2, 3, 4, or 6. We have the probabilities of each outcome. Next, we need their products. That's this dot here, supposed to be a times dot. We're going to times straight down 2 times 4, 25. Let's go decimal. So 2 times 4 divided by 25. Looks like 0.32. You could go fraction, you could go decimal, like you could go 8 out of 25 if you wanted to keep fraction, but I just went 2 times 4 divided by 25. That looks like 0.32. For 3, we're going to do 3 times 9 divided by 25. That looks like 1.08. And 4 times 8/25. 4 times 8 divided by 25 looks like 1.28. And our last one is 6 times 3/25. 6 times 3 divided by 25 looks like 0.72. We have our outcomes. We have those probabilities. We have their products. Finally, we are to add each of the values in the bottom row. 0.32 plus 1.08 plus 1.28 plus 0.72 gives us a expected value of 3.4. So if this process were repeated multiple times, the average number of puppies to be checked is 3.4 puppies. And that is expected value. Next example looks like my scroll's not working. Okay, a fair six-sided die is rolled. If the number shown is even, you lose a point for each dot showing. If the number is odd, you win a point for each dot showing. Find the expected value of one roll. If the number is odd, you win. So we're going to win 1. If the number is even, you lose. So we're going to lose 2. I'm going to fill out my die numbers, alternating win, lose, so we can win 3, or lose 4, or win 5, or lose 6. What is the probability of each outcome? Well, die rolls are independent, which means they are equally likely, so every single one of these answers is going to be 1/6. I think I'm going to stick fraction rather than switch to decimal, because that'll be easier for me to add up, because I'll have 1/6 minus 2/6 plus 3/6 minus 4 plus 5 and minus 6. I chose to stick fraction because with the common denominators, I'm basically doing 1 minus 2 plus 3 minus 4 plus 5 minus 6, which leaves me with negative 3/6, right? Negative 3/6, denominator stays the same, which is the same as minus 0.5. So I would expect to lose half a point on average each time I play this game. 1 time, okay? If I play this game 10 times, I just got to times that by 10. So that's going to be lose half a point each time times 10 times, lose 5 points. So let's pretend it costs you $1 to play this game after playing 10 times. Sure, maybe you won 5. Sure, maybe you won 3. But on average, you would lose $5. And that is all the notes for this lesson. Good luck on the exercises, and please let me know if you have any questions.